Hello again and welcome back to Mechanical Engineering Practice and Graphics. This week we're going to cover the chapter 6 of the book, Creating Reference Geometries. Again, I would like to start with the schedule. We are in week number 6. Last week there was no homework, there was only the midterm. This week there will be homework. We are going to do the fourth homework of the semester. And also, during this week you will form the groups for your final project group. Um, so that's important this week. Search for members in your group. As requested by a student, I created a group me chat. Here is the link. You can just copy this. The group is open, so anyone can join it. And remember to create this list with the members of your group, including the names, their phone number, their email, and any platform that you prefer to use to communicate amongst yourself. Now, um, the for the groups, I will allow you to do groups between 4 to 6 members. Try uh, to to be 5 or 6 because at the end of the semester, some people, for different reasons, will just stop replying emails or not answering phone calls, and some people will just withdraw the course for different reasons. So it's always better to have several members in your group. Now we're talking about the final project. Here are the rules. The idea is that you are gonna model, assembly, and prepare the technical blueprints. Also with a design presentation. So it can be either a poster or a PowerPoint presentation. And also a written report. I'm gonna submit to Blackboard a Word document that you can use to do your written report. And the idea is that you are going to model any vehicle of any kind. So you can model a car, an airplane, a boat, rocket, I don't know, a skate with a lot of details, a bicycle. So the rules are each group must have at least 4 members and a maximum of 6 members. Each member of the group has to do at least 5 parts. So, for example, if your group has 5 members, your project must have at least 25 different parts. Okay? And each of these parts should have at least 3 different features. So, one extrusion, one revolution, those kind of things are features. Okay? And I'm going to allow you to work with the students from both sections, OL2 and OL3. For the final project presentation or poster, you will have to include an abstract, an inspiration, a concept drawing or blueprint. You can do this by hand, and I'm going to show you in further slides. You will have to formulate the problem, like why do you want to model what you're going to model. You're going to show the assembly and the part distribution in the model, and also state any problems that you might have faced during the modelation. Any parts that you needed to redimension or to modify, that's fine. As you saw during the schedule, each week each of the members will have to upload their parts. This is just like a checklist that you are actually working during these weeks. Um, and since each member has to upload at least 5 parts, that's why we have 5 part submissions. Uh, you will submit everything, the full package, on the last week of classes, on November 30 to December 4th, that week 15. And the final project presentations will be during the week 14. So you will have to prepare your presentation or your poster and be prepared to answer any question that I or other students might have. Also, you will have to do a final assembly render. I'm gonna show you today how to do renders. Basically, this is adding colors or textures to your parts. Finishing with a conclusion. Of course, you will have to show during your presentation the full assembly of your vehicle, either in SolidWorks or through pictures, that's fine. So the grading rubric will be the following. The presentation or the poster will be half of the grade. Um, I'm going to grade the quality of your presentation, the content, and the design of your presentation. Also, we're going to grade the clarity and coherence of the information that you provide during your presentation. And if you show all the required components of the project. Okay? Now, when you submit the full package, you will have to submit all the part files, and I'm gonna explain during the semester what is the difference between a part file and an assembly file. Basically, in the assembly, you take all the different parts and put them together to create an assembly. And you will have to do two blueprints. One of them is just the technical views of the whole assembly, the front, right, top, and isometric with general dimensions. And when I refer to general dimensions, these are the maximum dimensions, the maximum height, the maximum width, all these maximum dimensions. And the second blueprint that you will have to present is an exploded final assembly with the balloon callout or list of materials. So you will show all the different parts in a list of your assembly in a table inside your blueprint. And we're going to learn how to do all of this during the semester. And finally, the written report is the other 25% of your grade. It's just a technical report in which you will highlight your process, what like a diary. So in week 1, what did you do? What were the challenges? How did you overcome them? Uh, for all the 5 weeks that the project is gonna take. You will show again your blueprints in your written report, and you will, of course, do a short introduction of the model that you're doing. Now, the idea behind this is that you are going to learn how to present a design, like if you were trying to sell it to me. So you're gonna be selling your design basically, and you will be learning how to work with others in a group. As engineers, that's what we expect from you. So don't be shy. Just speak with your classmates and coordinate. And of course, in every group must be a leader uh, trying to coordinate everyone else's. Uh, Decide quickly who is going to be that leader and the model that you're going to do. Because in next week, I will ask you to show me a blueprint. It can be handmade. It doesn't have to be uh, with a lot of detail, just a general idea on what you're gonna model. So start thinking by now what is gonna be your idea. And this is just a reminder. Well, for when you submit everything to Blackboard, you will need to submit everything in a compressed folder because the assembly file only works if the part files are in the same folder, and the same goes for the blueprints. It will only work if the part files are in the same folder. So just create compressed folders with all the files and when you're going to submit them. If you don't know how to compress a folder, that's fine. Here are different tutorials depending on your operating system. If you're using Windows, then just click on this video. It's a really fast video on how to compress a folder. Remember that if you don't submit everything together and the assembly doesn't work or the blueprint doesn't work, well, it's like a faulty file or a file that is not working. It will cost you points. So just learn now how to compress a folder and learn how to put everything together in the same place, basically. Here I have a bunch of examples of previous projects. In this case, this group model some sort of robot. They came up with all the dimensions, all the geometries, everything, and that's fine. You can do that. You can create your own model. However, I don't recommend to do this because it's really difficult to when you're going to put all these different parts together to make them to fit them together. It's a problem. Uh, and some people like to work in inches. Some other like to work in millimeters. So just decide from the starting point your units, and and I rather just recommend you to not to create something from scratch. I mean, there are things that you can measure in your house. For example, a bicycle. These are just previous bicycles that other groups have modeled. You can just go to your bicycle with a tape measure and measure different components, and that's easier. I mean, at the end, you will be just doing the the simulation or the model of your real bicycle. So you always can try to do something that you already have. It can be a bike, or if you want to do a car, you can go and measure your car. That's fine. There are also blueprints available online. For example, this toy train is very popular. It only has like the train and one wagon, but once you do one wagon, you can do more. And that was because this group had a lot of members and they needed more parts to be modeled, so they just add more components to it. But basically, you can find all the blueprints for all the parts of this toy train online, and I'm fine with that. If you want just to replicate that model, that's fine. Just try to be creative, and if you want to include your new ideas, that's even better. For example, these guys just took simple geometries. They modeled this Cybertruck, and of course the outer geometries are really simple to do, and you can just come up with the dimensions with pictures, I guess. But then they tried a little bit harder, and inside they created all this nice cockpit. They created the cup holder, the cup, even the steering wheel and the chairs. They even include the license plate with COVID-19. Um, this was last semester, and that's why they included this nice detail. So you can do that. You can just take really simple geometries, and then if you are lacking of parts, you can just create a nice interior and be very creative. Again, they added all these textures and colors to every component. You can do a poster. So this is just an example of a poster. These guys created a fire truck. This is an example of the blueprint with all the parts that they did. They were 5 members, and that's why they have 25 different components. So for example, if you're going to use one wheel 6 times, it doesn't count as 6 different parts. It's only one part used in 6 different positions. So as you will see here in this table, we have quantity, and some of those parts were used several times. So what I'm counting is not the quantity. What I'm counting is the number of items that you add in your model. Okay, just to be clear. And this is a really simple poster design. They included like some general views of their truck with an isometric view, and then just a quick description, and that's fine. But I rather you do a full presentation because you can give more details, you can explain better, and doing a PowerPoint presentation is really easy. So I just recommend to do the PowerPoint presentation. These guys did this Mini Cooper pretty good. If you see the resemblance of the model is really similar to the actual car. And this group, there were like 2 members only or 3 members. They weren't that many people. Okay, let's start. That's all for the project. Again, if you have any questions, send me an email. We can use the group me chat. Uh, I try to reply as soon as I can. Of course, I am a grad student and I have other things to do, but I try to reply as soon as I can. And if you have any suggestion to the course, to the project, I'm open always to hear them. So don't be shy. Uh, I like when people is participating in the course. Okay, um, let's start by creating this kind of chair or this model in SolidWorks, really simple model. And for that, I'm gonna use the front plane. I'm gonna create a new sketch. You already know all of these steps. A circle and then an arc here. Now this circle is 20 millimeters in diameter. And the arc upon it's 20 millimeters in radius. Okay. And then I'm gonna add these long lines, 30 and 40. Now here I would like to add the lines for construction as I should have done from the beginning, as I always do. This line is 30 and this other one is 40. Okay. And then we have 10 here in the bottom. And we have 10 here. Okay, now I want this line and this line to be the same length. So they both are equal and they both are collinear. What other relation am I missing? That this line, a relation, and this other line are also equal. And that this line and this other line are both tangent. Okay, now it is fully defined as we see here in the bottom. I'm going to just exit this sketch. And then for the extrusion, we have that the higher part, it's 10 millimeters in extrusion. I'm going to select this sketch here. And then in select contours, I'm going to select the higher part, 10 units. And then I'm going to deploy here and use the same sketch to create a second extrusion. Here in select contours, I'm going to select this bottom part. And this one is 30 millimeters. And that's okay. So we have our part there. Okay. Now that we have this part, what I'm gonna show you is how you can add more planes and more axes if you need to create eccentric models from your part. So basically we can create auxiliary planes as references if we need to do something additional on these planes. And here I would like to highlight the default planes that we have. So if you see here, we have the top plane, sorry, the front plane, the top plane here, and the right plane here. But then what happens if I need to do something like in between? I can just go here to features and then here to reference geometry, and I can create a plane. So as you see here on the left, we have several options: first reference, second reference, and third reference. For this first example that I have here, I'm gonna use the first two references. And those references are gonna be this plane of my sketch or of my model, and then this other plane here for the second reference. Now, since I am using two different faces and those two faces are parallel, uh, by default it will recognize that I want to obtain the mid plane of those two faces. So I can just click OK. And there it is. I have plane 1. This would be a auxiliary plane, and we also have it here on the left. And then I can create a sketch using that plane if I need to. Another example of this is we can do offset planes. For example, let's create a new plane using reference geometry here, plane, and then using this face. And as you see, I can move this plane left or right, or even flip the offset, or I can even do several planes here. So you can do that as well. And we have here the second plane. This plane 7 that is shown here, it happens to be the same right plane, but let's go ahead and try to do that one. I'm gonna just deactivate these ones. And the way to do that one, we can select plane. I can select this circle and then this face. But instead of making it perpendicular to this face, I can make it parallel. So I can create a tangent plane to this circle. Or instead of selecting that circle, I can just select these two faces and select midplane here. And there we have that plane that is going through the chair. This is something that I use sometimes when I'm grading you. I create these planes and then I use section view. I'm gonna do that again. I just select the plane that I want to use, plane 3 in this case. And then here on the top I use the section view. And then click OK. And there it is. I can see your model in section if I want to, or I can just deactivate it again. Now for adding planes, you don't always have to select a face. You can also select an edge like this one. So let's go ahead and create another plane here using this circle and then this line. And as you see, it will recognize that is the plane that is tangent to this circle, as we see here on the left, and that is coincident to that edge, H1, coincident. Or we can define it to be perpendicular, but it will create a problem with this tangent restriction here. So let's just keep it coincident. And that will create this third example that we have here on the right. You can also select corners. For example, 3 points, for example. Let's create a new plane, and in this case we're gonna select this point in this corner, this other point in this corner, and then this other point here. and we can have that plane. I can even hide them if I don't want to see them by right clicking on them here on the list and then hide. Or I can select several at the same time and do it. Maybe I just want to see one of them. That's it. Also, I can create planes using two edges. For example, let's select this edge here and then this edge here on the back. And it will create a plane that goes through those two lines. As you see there. Now we can also use the intersection between planes to create axes. For example, I'm gonna create an axis here using this plane that I created and this other plane. And you will see that that yellow line is actually the intersection of those two planes in the space. I can also create axes using circles or cylinders like this one. I will create that axis there. So you can use these reference geometries in a lot of cases, creating points or even coordinate systems. Uh, for example, if I need to do maybe a revolution far from this chair, for example, let's create a new plane like here probably, and then I want to do a revolution there, maybe a sphere. So I can just create a new sketch, Control 8, and then like a ball. And then I can just cut this part. A full revolution using this line. So look, I can have something far from that model. And you can create more parts from far from this. So that's the purpose of adding these reference planes or reference axis as well. I haven't shown you how you can do cuts using the revolution tool. So let's go ahead and create a new model. And in this new model, we're just gonna do a box. It really doesn't matter the dimensions here. This is just to show you the process. Now on the surface of this box here, I'm gonna create a new sketch. And here I'm gonna start by defining like an axis of revolution. And then a profile. And maybe I want to use splines. Something like this. Now this time, instead of using revolve boss base, I can use revolve cut. And I can use this axis. And it will cut that geometry from this given material. Or what you can also do, and I'm gonna edit this feature. Maybe I'm gonna do another sketch here. Control 8. And maybe I just want like a circular profile of this. And then I'm gonna extrude this cut. But here I'm gonna activate this flip side to cut. So this means that instead of cutting this circular hole in this chunk of material, I'm gonna cut everything that is outside of that cylinder. Let's see what it does. You see? And then I have this weird cylinder with a revolution inside. Now here as well I can add uh, uh, a texture to this revolution. For example, we go here on the right to appearances, scenes, and decals. And then we can select any of these materials, maybe a stone, like this one. And then I can either apply it only to the surface, to the revolution, or to the whole part. In this case, I only want to the revolution. And there it is. I can add that kind of textures to my model. You can even upload a picture if you want, an image, uh, just to play around with that. Okay, I'm gonna do this tutorial now. Uh, this tutorial will not be graded, it's just for you to learn how I can integrate some of the things that we did today in a model. And then I'm gonna show you the assignment for this week. So let's go ahead and create a new part. And for this new part, I'm gonna start by creating like a rectangular base here. So for this base, I can use this profile here that we have. And these maximum dimensions here, 250 plus 25 on one side and 25 on the other is 300. So using the front plane, I'm gonna create a new sketch. Again, I will start by adding the infinite lines for construction. And I will start by doing this rectangle here. Now the height of this rectangle here is 25 and the base is 300. And then I know that the distance between this edge and this line is half of this 300. It will be 150. And then I'm gonna create two arcs starting from here from the origin. One of those arcs has radius 80, as we see here in the figure, 80. And the other one is 105. Okay. And then I just have to delete those extra lines that I don't need. So for our case, I just need to delete this line, this one, and this one, and then this one and this one. And now as you see here, this line is blue and this point is blue, and that's because I can just well, it seems that I haven't defined this line to be horizontal yet. So I'm just gonna click it here, horizontal, and that's it. As we see here down in the bottom, it's fully defined. And now I can use this total width, which is for this analysis is 114, I guess. Yep. So I just extrude this sketch using the mid plane option, 114. Now I'm gonna activate the planes that we have here, and I'm gonna use the one in the bottom, this one, to create a new sketch. Like that. I'm gonna hide those planes. And again, I'm gonna start by creating those infinite lines for construction. Going through the origin. And then I'm gonna add a circle here that is tangent to this line, and another one here with the same behavior. Now those two circles are equal because they have the same radius. And then this circle and this line should be tangent. And the radius of those circles is 25, so the diameter is 50. I should also define this one to be tangent. And then I have two more circles here of 75. I'm gonna leave it this way because I need to modify this extrusion. So editing feature here, instead of 114 it was 150. And then I can continue editing my sketch. So maybe I don't need this circle after all, I only need this one. Like that. And then I need to add a line here from this circle to that circle. By default it already did it tangent to those two circles. And I'm gonna use the mirror entity here to copy that line. And then these two lines are gonna be again copied to the other side. And I'm gonna just delete what I don't need. this line, all these arcs that I don't need. But I should define this length between these two arcs, which is 250. That it's already there because they are tangent, so that's fine. And then I'm just gonna exit. Now, as you remember, in the previous example, I can just do an extrusion of this shape and cut everything that is outside this shape. So I can extrude a cut of this second sketch. I'm gonna flip the direction and also flip the side to cut. And here I'm gonna click in through all. And then OK. So we end up having this geometry, which is similar to what is up here. Now I'm gonna do those two holes, those two small circular holes of diameter 25. Again, using the top plane here, I'm gonna create a new sketch. And all I need is just two circles. Those two circles has the same diameter, so I'm gonna just define them to be equal. And that diameter is 25. The distance between those two is 250. And of course, equal space from the origin. And they are aligned with the origin, horizontal, and the same for this one. And that's it. They are now fully defined, so I can just exit this sketch and extrude a cut, flipping the side, and instead of doing blind, I'm gonna say through all, and click OK. So there are those holes there. Now I have to create a reference plane. So I'm gonna use I can either use the top plane or any of these two surfaces here. So I'm gonna just use the top plane and click here on reference geometry and then plane. And this one, it's at 150 as we see here on the left. So I create that new plane there. And using that plane, I can create a new sketch. And this sketch is in this top view will be only these three circles that we have here. 150, 75, and then 100. Now, this weird dimension that we have here, it means that there is a circle in diameter 100 that is cutting the material only 20 millimeters, and that would be this big cylinder here. And then the other one that is 75 in diameter will go through the entire material. So it's just a hole in there. So here I just have to do three different circles. The biggest one has diameter 150. And the other ones has 175. There they are. I can exit this sketch now. Okay. So we can use this same sketch for different purposes. I can use this sketch to do first an extrusion and then to do the cuts. And that's what we're gonna do. So I select the sketch and then extrude. Now here in select contours, I'm gonna select all the three circles. I'm gonna switch the direction or reverse direction. Here, these two arrows on the left. And instead of selecting blind, I'm gonna select up to surface. So I can define the surface in which the extrusion is going to stop. And that will be that surface in the bottom. So we have that cylinder there, and now we have to do the holes. I could just do more sketches here and then do the extrude cut of those circles, or I can just recycle the previous sketch that I use here in the second extrusion and then create a cut. Now for this one, I'm gonna select only the inner circle. Here in the select contours, I select the inner circle and then I can select through all, because that's the hole that goes through the entire material. And then again, using the same sketch, I can select another cut and then only this cylinder here. But this one will go only 20 millimeters. And that's it. That's our model there. If you want to see the viewing section, that this line here with these double A's on both sides, they are marking a section view, which is what we have here on the bottom. This is the section view. And then this looks pretty much the same as this section view. Now, we can add appearances to this model. So for example, I'm gonna use a metal here, maybe brass for the base. Maybe here, can edit the appearance as well. So I will select brass. And maybe I will select a different material for the extrusion. Maybe diamond for this extrusion. That would be weird because then we will see through the material even though these surfaces are brass. So I'm just gonna reverse that. Anyways, you can add appearances to different operations on your tree. And then here in SolidWorks Adds In, you will have to activate the Photo View 360. Will take a moment, and then it will show the render tools here on the left. I'm gonna deactivate this plane as well. Maybe the viewing section should be interesting. And then here in render tools, we can click in final render. So once I have my, like the view that I want to render means to draw in the computer. How can I explain this? Let's just do the final render and you will see what I'm trying to say here. Here I will click in continue without camera or perspective. It will open these new windows here. And the computer is now drawing that brass material, making it like realistic. I can just increase the zoom here, maybe, and then I can save this image. Render 2, and then we can look for it. Here we have the render 2. But I would like to show you how I did the render for the homework. So this will be your homework. Basically, you have the same rules apply. You will have to do the SolidWorks part, take screenshots of your progress and submit the PDF. And then this is the geometry that I want you to replicate. I think it's something very easy. You can even do one single sketch and then do several extrusions. Again, this assignment is due by next Sunday midnight. But the addition here is that I would like to see if when you finish the model, you can render the model. You can add any appearance that you want, any material or any color that you want, and then just do the render. Now, once you have the render open, try not to move this because every time you move your model, the render is gonna do it again. We'll compute everything again, and it just kills your graphics card. So once you have this open, try not to modify what you are viewing in SolidWorks because this makes your computer super slow. And then maybe I can just save this preview image. Yep, and here is the preview. Okay, so that's it for this week. Please remember also to do the list of the members in your group with all the contact information necessary to coordinate your project. Now you know that you have to do a vehicle, that you will have to do either a poster or a presentation and a written report. So divide the task. First, select what you're gonna model: a bicycle, a train, even a helicopter. I don't know. You're free to decide. Gather all the contact information and then divide the work. Who is gonna do what in your model? Please, if you can, attach also this small list with the members of your group along this homework, so I can see who already has a group or who needs me to find a group for him or for her. I'll give you this week to decide that, just for you to give you the freedom to select who you want to work with. If by next week you don't have a group yet, then I will just pick one group for you and that's it. Let me know if you have any questions. Again, I am available in the group me chat or via email, as you prefer. Have a good day, everyone, and good luck with this new homework.